back to my YouTube channel. As you prepare for the forthcoming JAMB 2025 and you come across this question on energy consumption, this is how you are going to do it. Let's dive into it. If the charge of electricity per kilowatt hour is 4 naira, what is the cost of operating an electrical appliance rated 250 volts, 2 amperes for 6 hours? Option A, 16 naira, option B, 24 naira, option C, 28 naira, and option D, 12 naira. For us to solve this problem, let us set our parameters. We are given the cost. So 1 kilowatt hour is equals to what? 4 naira, right? Now we are looking for the cost, but we are given the PD, potential difference, to be 250 volts. Now we are given the current to be 2 amperes. Then the time to be 6 hours. And the first thing that will come to your mind is this: what is power? Power is equals to what? IV, that is current multiplied by time. So let's get the power. The power is equals, my current is 2 multiplied by 250, then it's going to give me 500 watts, right? Now the next for us to do is to convert this power from watts to kilowatts simply by dividing by 1000. Now this is 500 divided by 1000. This cancel this. So my answer is 0.5 kilowatts. And remember that energy is equals to power multiplied by what? Time. What's my energy, which is also the same thing as the cost? Now, the energy, my power is 0.5 kilowatts multiplied by my time is what? 6 hours. Okay? Now, by the time you multiply, you're going to have 3.0 kilowatts hour. Is that clear? But from the question, we are given that 1 kilowatt hour equals 4 naira. So what is this one going to give us? Okay, so let's go. So let's go by saying 1 kilowatt hour costs 4 naira. Okay, now therefore 3.0 kilowatt hour, therefore 3 kilowatt hour is what we are looking for. That is X. So if we do cross multiply, the cost is equals to 4 multiplied by 3, and that will give us 12 naira. And that will give us 12 naira. I hope that is clear. Now, in a nutshell, what am I trying to say? I'm trying to say that if you are asked to calculate the cost of operating an appliance and you don't have power, you're going to get power first. But in some question where you are giving the power already, you don't need to solve for the power. You just convert it to kilowatts simply by dividing by 1000. Okay, then you now multiply by the time, because energy is power multiplied by time. All right, so by the time you do that, you can now see that you can now equate it by the cost given the question, and the answer becomes 12 naira. So from what we have gotten so far, the correct option to this question is option D. An electric bulb is labeled 260 volts, 80 watts. How much current is taken by the bulb? Option A, 0.46 amperes. Option B, 0.82 amperes. Option C, 0.40 amperes. Option D, 0.31 amperes. By stating your parameters, you should know the formula we are going to use. Okay, so we have the PD as 260 volts. We have the power as 80 watts. Okay, and we are looking for current. Now I want to remind you that the formulas of power, P equals IV or I square R or V square over R, right? They are all equals to power. If you multiply all of this by time, it's going to give you energy, but we are not looking for energy now. Okay, so the formula you are going to use in this context is what? P equals to IV, because we're looking for the current and we have potential difference with the power, right? So let's go. You say P is equals to IV. So my P, which is power, is 80, is equals to my I, is what I'm looking for, multiplied by 260. Okay, so divide both sides by the coefficient of I, which is 260. This cancels this. So my current is equals to 80 over 260, right? Then I cancel this, okay? Then 2 into this is going to give me what? 4. 2 into this is going to give me what? 13, right? So by the time I divide, now we say 4 divided by 13 is going to give me 0.307 amperes, right? Then approximately becomes 0.31 amperes. Is that clear? So from what we have gotten so far, the correct option to this question is option D. The cost of running 560-watt lamps and 400-watt lamps for 20 hours if electrical energy costs 10 naira per kilowatt hour is what? Option A is 280 naira, option B 160 naira, option C 120 naira, option D 140 naira. Now in this question we have different types of power. We have 560-watt lamp and 400-watt lamps. We are going to add them together, right, to get the total power. So P1 is equals to, we have 5 multiplied by 60, okay, that will give me 300 watts. Now the P2 is equals to, we have 4 multiplied by 100. 4 times 100 watts is going to give me 400 watts, right? So we are going to add them together by saying the total power is equals to P1 plus P2, right? That is P is equals to 300 plus 400, which is going to give me 700 watts. That is just for the power. The next we are going to use to get the power in kilowatts. So simply by dividing by 1000, you say P is equals to 700 over 1000. This cancel this. It's going to give me what? 0.7 kilowatts. Now the electrical energy is equals to power multiplied by time. That is 0.7 multiplied by 20 hours. That will give me the energy to be 14 kilowatt hour, right? And from the question, 1 kilowatt hour costs 10 naira. You must always make use of the cost given in your question. In this particular question, a kilowatt hour costs 10 naira. They will say 1 kilowatt hour is equals to 10 naira. Then therefore 14 kilowatt hour is equals to X, right? Simply by saying cross multiply. Then the cost is equals to 10 multiplied by 14. That is going to give me 140 naira. Is that clear? Now this question is different from the one I solved previously. Reason is because the powers we are giving, we have different lamps and their power, so we need to bring them together by adding them separately, then multiply them separately, then add them together to get the total power before converting it to kilowatts, after which we'll now find our energy, okay, and relate it to the cost given to us in the question. And from what we have gotten so far, the correct option to this question is option D. What is the total electrical energy consumed by using an electric cooker rated 1000 watts for 5 hours? Option A 5.3 times 10 raised to power 3 joules. Option B 6.5 times 10 raised to power 3 joules. Option C 1.8 times 10 raised to power 7 joules. Option D 2.3 times 10 raised to power 7 joules. And in this question we are looking for electrical energy, and electrical energy E is equals to PT, right? Okay, so what is our power? Our power is equals to 1000 watts. Then what is my time? My time is 5 hours. So what we must do here is that we must convert these 5 hours to seconds simply by multiplying by 3600, okay? You say T is equals to 5 times 3600. And do you know how we got this 3600? For you to convert from hour to minutes, you multiply by 60, and from minutes to seconds, you multiply by what? 60. That sum up to 3600 seconds. By the time you multiply, it's going to give us 18,000 seconds, right? Let's solve for our energy. Energy is what? PT. What is my power? My power is what? 1000 multiplied by 18,000 seconds, right? Now by the time you multiply, it's going to give me 180000, right? Okay, now this is what? Energy. Energy is measured in joules. Now I want this answer to be in standard form simply by saying 1, 2, 3, 4, 5, 6, 7. So this is 1.8 times 10 to the power of what? 7 joules. I hope that is clear. So from what you have gotten so far, the correct option to this question is option C. In the diagram below, if each of the resistors can dissipate a maximum of 18 watts without becoming excessively heated, what is the maximum power that circuits can dissipate? And we have option A to be 27 watts, option B to be 18 watts, option C to be 9 watts, and option D to be 5 watts. Simply, we are looking at this diagram as an illustration. Now, if this diagram below is being replaced, now this 2 ohms is being replaced with what? 18 watts, 18 watts, and 18 watts. So you're looking at the maximum current that this circuit can dissipate. It simply means they are replacing these ohms with what? Power, right? Now these ones will be in what? In parallel, while this is in series. We are going to solve it the way we solve resistors in series and parallel connection. So let's go. So for us to solve, we say power in parallel. So that is a short method of solving for power in parallel. We have P1 times P2 all over P1 plus P2. Okay, that is 18 times 18 divided by 18 plus 18. 18 multiplied by 18 is going to give us what? 324 divided by 18 plus 18 is going to give us 36, right? So by the time you divide, it's going to give us 9 watts, right? Now this 9 watts is for these two powers in what? In parallel. So it's now in series with this one. So we have like this. So this is what? 9 watts, and this is what? 18 watts. Okay, this is 2 ohm but carrying 9 watts, while this is 18 watts. Now by the time you get the total power, is going to be P1 plus P2. That is 9 plus 18, which is going to give me 27 watts. Do you understand? So it simply means that the way we solve resistors in series and in parallel is the same way we solve powers arranged in series and in parallel. I hope that is clear. And for what you have gotten so far, the correct option to this question is option A. Thank you for sticking to the end of this video. If this video was able to help someone, please don't forget to subscribe to this channel, turn on the notification button to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this forthcoming exam can see it and learn from it. I'll see you next time in the next one. Bye for now.